Hello everyone. It's the part 2 of the mechanics resisted projectile motion quadratic drag model that we're going to use R equals minus kv squared. Okay, so this is just a before introduction before we start the components. So these are the exactly the same as the linear drag models, except for now v is squared, not v. So it's not linear, it's quadratic. So let's start. Horizontal components, I'll just start that first and then I'll come back to the vertical components. Okay, so here we will start with the exactly the same, except for its x dot is now squared. Okay, so that's not too bad. So, and then x dot dot a, which is a, equals minus k over m x dot squared. Now I'm going to change that acceleration in terms of a dx dot over dt, and then I'm going to swap this with this dt with x dot squared for a smooth integration. Now this will be like dx over x squared, really, if you think about it. So I'm just going to make it into index form. Okay, so it'll be x dot minus 2 dx dot equals whatever that, and I'm ready to integrate. So if we just normal integration really, and then we'll put the t there and then constant, and then that will be like minus 1 over x dot there, and then again the initial condition is exactly what we talked about as a linear drag model as well, similar, well, exactly the same, and then we'll get the c equals minus 1 over v cos theta. Okay, so that wasn't too bad. So now from here I'll put it back in to my c spot there, and then what I'm going to do here is I'm going to make everything positive, so times by negative perhaps, so I will get that, and the whole point is I want to make the x dot the subject. Okay, so I'm going to make that is my common denominator will be mv cos theta, so I'll sort that out the numerator, and I'll just flip there, and then I just want to get rid of the m, so I'll just take the m out, and that's what I've got to get, and cancel the m out, that's what I get. It's I don't really need to do it like a miss, why do I have to? Oh, can I just leave it like this? It is okay, but we got more to go, guys. We've got to go to the displacement, and this is the best way for us to integrate. If I leave it like that, it'd be a bit messy, so I'm just going to make it this a little bit better for integration. So integrate, x dot will be x. Now on top here, it's a dt, so I want that to be in a km v cos theta. So that's what I get to do it. I mean, if you left it like that, you can still do it. It's not a huge difference. And then I'll get ln, obviously, that's the whole point of we sorting things out to get the ln plus c. And then after this, the condition is t equals 0, x equals 0, I'll put it in there, and c equals 0. Why? ln 1 is 0, so the whole thing will be 0, c equals 0. Nice. And then we'll get the displacement equals the whole thing, but no c. Okay, so that's like that. All right, so we got all the horizontal components right there. Now let's have a look at the vertical components. So, okay, so we'll start it from exactly the same as a linear drag model. It's not a huge difference, except for it's the squared. That's all. Now this time I'm going to use this expression. It's just easier for me, and then you will see why. So I made this one into 2 parts, and then I'll take the minus out, and then I'll swap that to dt, completely swap, but leave the minus there, and integrate. Now this is the part why I use this one, because that looks like a inverse 10, doesn't it, if I change the square plus something square. Now this is the part it's going to be really challenging for some of you. Now when I use the inverse 10, now that has to go out, right, as a 1 over something, so it's swapped, and that will be out as a 1 over. And then whatever it's left here, you have to put it back in as well. G has to go in, so it'll be k over mg. Okay, so don't forget the g in this part. You've probably done okay here, and you forgot about g there. It's going to be a problem. Okay, so be very careful on this. Okay, all right, if you need more practice, get some more questions like inverse 10. Okay, and then we got that, and of course the original condition, when t equals 0, the velocity, the vertical velocity, equals v sine theta. Okay, so that's not too bad. So we put it back in, and we'll get c equals this. So this is going to be pretty small writing that I use. So what I'm going to do, I'm going to move this a little bit here. So I'm going to put that in. So that's my little c there. So put that in there. Okay, so that was my little c. Put it in there. So now I'm going to move t to the here and move this one to there. So that goes here, that goes minus here. Yeah, can you see that? And then I'm going to tidy it up a bit. So I'm going to take the square root of m over gk as a common factor, and I've got inverse 10 here minus inverse 10 here. Now this one looks very familiar, doesn't it? This is the sums and difference of the angles. So it's a 10, so that's what I'm going to use. And then what happens, I'm just going to move this one to the front, so that I'll just have this. So I've got, and then I'm going to take the 10 tangent on the both side. So then I'll get 10, that equals 10 a minus b. Miss, what happened to this? Now what I'm going to do is I'm going to let this is a, let that as a b. So that's what happens. So when I do that, let a equals this will be, I move the inverse 10 to the other side, it'll be 10a equals that, and that will be my b. But I move the inverse 10 to the other side, it'll be 10b, it'll be that. Now why did I do that for? Because here this 10a minus b is this, so I can use the 10a 10b on there. Okay, you see what I'm trying to do there? So when I put it all in and then simplify it, okay, so here we go, here we go. So, and I do that, so let's have a look. So vertical, so I'm gonna put, I'll just see that. So this part here, this part was the 10 root m over gkt equals the whole thing here. So I've just made it into fraction, cross multiply. Okay, so I'm timesing this and this. Okay, so that wasn't too bad, just times by 1, the same. Now this one's going to be a bit tricky, but what I'm going to do, and then I'm going to expand. Okay, so just take your time, expand that, okay, so slowly. And then I've seen this one because I need to make it into y dot as my subject, so I'm going to collect the like terms, these two all in one side. Okay, so and then move that one to the other and take the y dot as my common factor, and I've got that. Now this is the part, we got this fraction happening here, isn't it? So we don't like fractions here. So what happens here, I've times by mg on the top and the bottom, and then I'll get that. Okay, so but then you will say, oh miss, but still in the fraction form, but it'll go. So now I've got that this one becomes this. Yeah, I'll just change that, and then that will be same as that, changing it. Okay, and then I'm going to times by mg, you see. So when I times by mg, because with this form I can't just times by mg, right? So when I times by mg, the fraction will go, okay, and then I divide by that on both sides, and I will get y dot as this. Okay, phew. So watch this a few more times and really understand. Now it's impossible to integrate this. We can't really have the displacement for y now. So that's pretty much it where we're gonna go. That's it, and we are time. This is time for a question. Excellent. So question 1, a 2.5 kilograms of Civil War cannonball is launched from the origin 0, with a velocity of 200 meters per second at an angle of 30 degrees to the horizontal. A drag force of magnitude kV square is experienced with a proportion constant of k equals 0.0001. Okay, so I just underlined all the important information there. And part A, write an expression for the range of the cannonball and find how long it takes it to reach 250 meters. Now there's 2 parts in this part A that you have to answer. One is the expression, one is the finding an hour, t, okay, when x equals 250. All right, so use the whole thing. I mean, you need to plan this really. So to find the t, you need to range with it in terms of t, don't you? And then you can use the x equals 250 to find the t. Okay, and then part B, find the how long. So that's a t. It takes the cannonball to reach the maximum height. The maximum height, automatically y dot equals 0. And its speed at that point. Yeah, speed, I'll just put the formula there if I were you. So that it's all good. And then use g equals 9.8 meter per second squared. Okay, so g was given. So I don't have to think about using a 10, but 9.8. All right, so before I start, I'll just draw a little my trusty right angle triangle with all the information. That was like what, 30 degrees, 200 meter per second. Therefore my the vertical velocity and horizontal velocity will be ready to go. Okay, so first thing first, first part A is this expression for the range. So I don't really need to worry about the vertical because it's just horizontal because x in terms of t, isn't it? So ma equals minus kv x squared. Now I didn't use m here because m was given, so m don't need to be used here. Okay, it's because it's not really going to cancel out, so I'm not going to use that. And about all the information I've got from the question is there, so I'll put it all back in. Remember, it's always starting point is acceleration, so you want it to be in a or x dot dot. And then you're going to change into dv dt because we want it to be x in terms of t. So we're going to go down to x equals. That's our goal. So when I do that, I'll get that. Now make sure everything, like here, I wouldn't leave this one as minus 1 over 0.00004. I'll just change into minus 25,000. Okay, that'll be a lot easier. And then I'll swap, okay, this 25,000 with dvx. I'll swap that. Okay, just easier to integrate. Okay, so I think the more you do the question, that you can predict. You can predict how you're gonna condition your equation just before the integrate. Okay, you'll get used to it. So don't don't worry too much if you didn't think about it. The more you do it, the better you'll be. And then I'll get that. That's just simple integration, isn't it? So I'll just go minus v to the negative 2, power of negative 2, and then I integrate, I'll get that, and then add it to plus c. And then I'll just times by 25,000 on both sides, and I'll get this, and put the initial condition, initial velocity, and then I'll get the constant, and then put it back into the t formula right there with the constant in it. And then what happens, we go to we have to make the Vx the subject, so I'm going to make that, move that one to the other side, leave that one, and I'm going to tidy this one up a little bit, and then it's just cross multiply, isn't it? So, and then we'll get that, not cross multiply, just times by 25,000. So I'll get Vx, and then I'll integrate again because I want to x equals. So taking that out, separate, because it's easier to integrate, because you can look at the bottom here. The differentiate of 250 plus root 3t will be just root 3. So I just want to leave the root 3 by itself. And then I integrate. Voila, that's what I got. And of course, my initial condition for the x is 0, t is 0. And I'll get the constant. I'll put it back into constant and tighten it up a little bit because it's got ln, and I'll just did that. All right, so that's the question. It says expression for the range in terms of t. I've done that. Now we have to find the how long, the time when x equals 250. Easy. So you just put the 250 there, and then we use the formula. Just make sure, just make it simpler, guys. So when I do that, 250 divided by 25,000, it'd be 1 over 100. But you don't want to put it in the e to the power 1 over 100. But it'd be easier if you just put 0.01. Okay, so we do that. And I'll times by 250 on both sides. And then take away 250. And then divided by root 3. And put that in the calculator. I'll get roughly 1.5 seconds. Okay, so the cannonball to reach 250, it'll take 1.5 seconds. Well, that's not too long at all. So that's good. And then part B. Okay, so part B is what's the time when it's a hit maximum height. So that's when maximum height, automatic. That's what we're going to do. So from the proof, we're going to use all these. From the proof, that equals 0. I think that will be given in the exam, most likely. They're not going to spend the whole thing proving. So when we do that, the whole thing will be 0 when you times it, and then you put all the information in there because it's just easier. When you put a number in, you feel better and safe, right? So we got all the information there. Just put that in, equal to 0, and that. But keep it in a sort of the compact sort of form. So don't put it in a decimal, but it's in a decimal, but in a square root form, but not like continuous, like a repeating or any sort of a format of the decimal. So it looks, we sort of, looks tidy up and nice and easy, simple. So keep going. Whole point is making t the subject, guys. So, and I put that in. Now, remember, this is not in the degrees. So make sure you put it in a radian mode in a calculator. Okay, be careful with that. And when you do that, you will get 10 seconds. So that's not too bad. So we got the how long part there. Now we got to do the speed, guys. So speed is what? X dot square plus y dot square. But because it's a maximum height, y dot is 0. Be careful with that. And therefore, it's just got s speed equals square root of x dot square, which is the x dot, yeah? At 10 seconds. And then you just put it in. What was x dot? The formula was this, okay? And then we got all that information here, right there, and substitute back in, okay? and you will get the speed is 161.9, and then to the nearest, that would be 162 meter per second. So the cannonball has speed of 162 meter per second at the maximum height of the trajectory. Okay, well done, people.